This is Hacker Public Radio episode 3559 for Thursday the 24th of March 2022. Today's show is entitled Linux Inlaws S01E52. The Zig project and is part of the series Linux Inlaws. It is hosted by Monochrome and is about 69 minutes long and carries an explicit flag. The summary is an interview with Loris Crow of Zig fame.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs.
Welcome to Linux Inlaws, Season 1, Episode 52. Martin, how are things?
Yeah, I think so. Good. How are you? And more importantly, how is our guest?
Can't complain, Martin, can't complain. But before we go into our guest, how is the situation shaping up in the UK? I understand that Lizzie hasn't stepped down yet?
No, she won't anyway. This is comes with the job, right? You don't get to resign.
So you can't resign, you simply die or whatever. I see. Okay.
Unlike, what's her name, Merkel? She resigned, didn't she?
Yeah, she resigned. Exactly, it's official. Yeah, she's going back into physics. There's an episode of
how many years of
16.
Of next government negotiations going to happen now.
About 12? Maybe I'm wrong. If you want to know, by the way, people, if you want to know about the future of Mrs. Merkel, as in the ex-German Chancellorette, there's an episode of The Dark Side last year, basically, that gives a little bit of a clue at what's going to happen.
Yeah.
And more specifically, the Halloween episode of last year. But this is not about the past, but rather about the future. So, Martin, why don't you welcome our guest?
Yes, tonight we have a special guest who is someone we know from a few years ago.
The past, yes.
Yes. Well, the recent past, let's put it that way.
Yes.
And he's heavily involved with a programming language, which
he
comes to tell us all about tonight.
Yeah, that was the point in time, basically, I think even before you defected, right?
Well, I think Loris defected first, if I'm not mistaken.
Oh, he did. Sorry, I wouldn't use the term defected now. But Loris, without further ado, why don't you introduce yourself, and all riddles will be resolved very soon.
Hello, guys. Wait, Martin, you defected?
Yes.
You always defected. I left.
That's his trait.
It's not an army, so there's no defection possible. Yeah,
he defected once again. Yes,
it's. I guess it's run by. Let's not go into the details of who's run by.
Loris, sorry. Before we drift into the internals, into the internals right away, why don't you introduce yourself, and then I'm gonna shed some light on all the defections that happened since you left.
Oh, okay, yeah, that makes sense. So hello everybody. I'm Loris Crow, and I'm currently VP of Community at the Zig Software Foundation. And we were saying that we were talking about defection a moment ago. So I joined the Zig Software Foundation after leaving Redis Labs, where I was a developer advocate. And I don't know, I guess I put my marketing skills that I gained at Redis Labs at use now. I'm putting them at use now at the Zig Software Foundation.
Yeah, this is, and full disclosure, this is how we all met.
Yeah.
Martin, myself, and Loris, of course, were working at Redis Labs when it was still called Redis Labs. Martin has defected and has defected since again. I'm still with Redis, as it's now called these days. But this episode is not about Redis or VMware or Brightlight or whatever it was called, Martin, but rather about the Zig, the programming language, and the Zig Foundation. Yeah. So, Loris, without further ado, why don't you tell us a little bit about the foundation and the programming language as such?
Sure. And also, I guess I need to do a good job, right, to convince you guys, because I listened to your last podcast.
You did?
I did.
Martin, that's a listener. Excellent.
Very good. You guys didn't sound super stoked by Zig when you were discussing it last episode.
Well, we don't know anything about it, so why don't you?
Indeed, we don't.
Enlighten us.
Other than it's a programming language.
Yes. So, okay, Zig is a programming language. We on the website we have this tagline where we say that it's a general-purpose programming language. You know what? I'm going to bring it up and read it directly. That doesn't sound super sexy, but here's the thing: I can justify each word, which I think it's more interesting exercise. So Zig is a general-purpose programming language and toolchain for maintaining robust, optimal, and reusable software. So the idea behind Zig being a general-purpose programming language is that it's a programming language that doesn't have like a runtime, and it doesn't have dependencies on things that you can find on like full-blown personal computers, but that maybe you wouldn't find in embedded devices. So, for example, you can't really program tiny embedded devices with Python without weird compromises. In Zig, you don't have that. It's a tool chain because you can use Zig to compile C and C++ code and cross-compile it, so like Linux to Windows, ARM to x86. And that is non-trivial. It's weird, but C and C++ have always been weirdly hard to cross-compile. And finally, the robust, optimal, and reusable is just how we like to describe how an ideal Zig program should look like, because Zig puts a lot of emphasis in handling errors. It doesn't have exceptions, for example. So whenever a line can error out, you know it because error is part of the return type and stuff like this. Also, we, as a language, Zig is very explicit. There is no hidden control flow, no macros, and like the general ethos of the language is to be easier to read than it is to write. Sometimes you write a bit more, but the idea is that who comes in and reads should not be confused by your code normally.
I like that.
Yeah. And it's like a modern C/C++/Rust contender, if you will. It's in the same ballpark, roughly speaking.
And how did it come about, I guess? Did someone just decide one day, I'm going to invent a new programming language, or was there something specific that he thought, this is no good in C or C++, or, yeah?
So I think that the story is... Okay, do you want to know the story that I like to tell people, or do you want to know the real story?
The truth and the whole truth.
Both actually, if it's possible.
Okay, so I'll start with the one that I like to tell. The one that I like to tell is that, so the creator of the language is Andrew Kelley, who at the time was working at OkCupid. And apparently OkCupid is a giant C++ code base. Even though it's a website, at least that's the part that everybody knows about, right? But apparently it's implemented in C++. So the story that I like to tell is that Andrew one day was put in charge of a messy C++ code base, and I told him, well, you need to maintain this. And he did the only rational thing, like the shortest path to maintaining a C++ code base it's to invent a new language and rewrite it in that. That's what I like to tell. But the reality is that I believe that Andrew has always been interested in audio processing stuff. So like making digital music, right? And if you want to do tuning that works with sound, it needs to be very efficient. You cannot have like garbage collection pauses, stuff like this. And so he looked at a few languages, and he wasn't happy with any that he tried, and so he ended up basically working on Zig.
So this is the official version. What's the unofficial one?
Well, no, the second one about audio stuff, it's the official version.
The
version that I like to tell is the OkCupid one, the one where he had to work on a C++ code base, but that one is not true.
Okay, so no Sicilians involved, no money changing hands, that sort of thing.
Not yet.
Okay. Full disclosure, I had a very brief look at the language over the last couple of years. Let's start at the beginning. Zig was invented about 2015, 2016, something like this?
Yeah, I think it checks out. I don't remember precisely when. There's also, the initial part where like it's a private repo, so nobody knows about it. Then it becomes a public repo, but then still nobody knows about it.
Okay.
I'm not exactly clear on that period, I guess. I joined Zig more or less around release 0.4, I believe.
Got it. Going back about 10, 12, 13 years, Go was just invented by Google. Mozilla had just dreamt up this, or somebody at Mozilla, sorry, I should probably be more precise. Somebody at Mozilla had just dreamt up this requirement for a new language because C++ and C didn't cut it anymore in terms of total cost of ownership of the code base, technical depth, and all the rest of it. Hence, Golang, or affectionately also known as Go, and Rust were born. Now, if I take a close look at Zig, it does remind me in certain quarters of both Rust and Golang. It's not fully object-oriented. It does support structs. That reminds me pretty much of Rust. Enums are very close to Rust. For example, if I take a look at the error type, and we're not getting too technical here, that reminds me of Rust. Where do you see the differentiator between, say, Golang and Rust in a Zig context?
So I think that there is some difference. So there are parts of the Zig syntax that kind of remind of Rust, but I know Zig. I've been doing Zig professionally now for a while, for more than a year. And I still, given that, I don't have an easy time reading Rust programs. So even though part of the syntax are similar, there are some big differences when it comes to how programs end up written at the end of the day. I would personally say, as a still imprecise way of describing the differences, but just as a first approximation.
By all means.
Yeah, I think that Rust is a language that loves abstractions and complicated stuff in the same vein that C++ does, while Zig is more on the C side of the equation, so on the side where you don't want to go too insane with abstractions. Now, that said, while I personally clearly am definitely in the camp of simplicity, so I definitely prefer the Zig approach compared to the Rust one. Obviously, there are some advantages to each approach. There's people who can make the C++ work for them beautifully, and so, more power to them. That's my point. But yeah, so that's the bigger difference. I would say then if we were to compare Rust and Go and see where Zig is in that spectrum, Yeah, maybe it's an in-between in some ways, although it doesn't map perfectly because Go is garbage collected, Zig isn't. I would say that Zig is a simpler Rust. It's a systems programming language in a way that I don't think Go truly 100% is. But on the other hand, it does share with Go an appreciation for simplicity. That said, Go likes simplicity to a minimalistic level that I think it's kind of unique of Go. And even though I like Go a lot, I really like Go, but I don't know, some things are a little bit too minimalistic for my taste nowadays.
Interesting perspective, Loris. Many people do say that Rust has a very steep learning curve. Having learned Rust myself, and full disclosure, I'm not. I wouldn't consider myself a Rust expert by no means. I dabble in Rust a little bit here and there, but that's about as far as it goes. I can concur with the entry into the program language, not the easiest one, especially given the concepts like ownership of variables, how memory is managed in Rust and all the rest of it. I fully concur with your observation that probably Rust is too heavy on abstractions. And it's an interesting perspective that you see this closer to C. Now, full disclosure, I'm really old, so I learned C about 30 years ago, give or take a few years. When I take a look at the programs and the website tells me apparently, because of the LLVM backend, you consider Zig to be a drop-in replacement at a lower level to be very similar or rather off C. How do you see this relationship from the huge code base that is out there with regards to C and Zig maybe being a logical successor to C in that regard?
Yeah, so we have an actual slogan for this. The slogan is "Maintain it with Zig," and it's on the website, but it's also the title of a blog post that I wrote a while ago. And I think that we're going to use it for something else also in the future. So the idea is this: you can use Zig as an in-place replacement for Clang. So there's a Zig CC command. If you do Zig CC, then that's a flag-compatible interface with Clang. So you have a C project, you compile it with Clang, you used to compile it with Clang, you can swap in Zig CC. Now, that alone doesn't sound too interesting. Why would you do that? Clang is plenty good. Why toss in another thing? Well, here's how it works. You toss in Zig CC, and your stuff keeps working. Then, with a tiny little bit of work, depending on how complicated your project is, you can tweak a little bit your makefiles to remove, for example, target-specific capability checks. Like, for example, you know how sometimes build scripts are trying to look if your system supports a given feature or not, but those are tied to your system. So if you remove those, and clearly you, you do that in a reasonable way, so that you don't like remove a check and then assume that something is true when it's not. But the point is, you do it correctly, and you can now cross-compile your project. We actually wrote a blog post series where we actually did this with Redis. So step one, replace your GCC or whatever, your C compiler with ZigCC. Step two, tweak a tiny little bit the variables that you feed into the makefile and add the appropriate flags to Zig. And it's literally just -target x86 Windows, x86 Linux, whatever you want. And now you can cross-compile. And we actually, in that blog post, cross-compile Redis. So we did it on stream actually while testing this stuff out the first time. So I was on a Mac and I cross-compiled a version for Linux and I sent to Andrew, and he was able to run it. And that's step two. So cross-compilation, enabling cross-compilation. And by the way, if you were to try to cross-compile a C project by yourself without Zig, it's a bit more complicated than just setting the target variable. You need to bring your own sysroot, you need to bring your own C library for the target, and there's a lot of work that you have to do that Zig does for you automatically. Step 3, though, and here things start becoming more interesting. Build scripts are sometimes like there's a soup. Projects have soups of build scripts, like they have a make file, but then make doesn't work on Windows, so they also add CMake because somebody likes CMake. Then somebody else likes something else. Windows needs its own batch files or whatever curse thing people do on Windows. So you have always these projects where they have, sometimes they commit the autoconf stuff, sometimes they don't. I don't know. It's a mess. Zig has a build system integrated in the language. So you create a build.zig file, and Zig can use that to basically do what you would do with make files. Now, this is interesting because if you do that, you remove your dependency from make, CMake, or all this stuff. So now the compiler is also the build system for you. So you reduce a dependency and made your project a little bit more multi-platform. And that's actually something that it's already being used by I can think of WASM3 and a few other projects in that space that are actually have adopted. They have a build Zig file in their repo. So if you have Zig, you can just run that and you're good. And that brings us to the final step. So here you can see the maintain it with Zig story fully complete. You have a C project. You keep it in C. You don't start rewriting it right away. But when you want to add functionality, you can create a Zig compilation unit that the Zig compiler will be able to compile. You will be able to export CABI symbols, functions, types, structs, and stuff that interoperate with everything. So it's one extra compilation unit like any other compilation, C or C++ compilation unit that you would have. Although we are limited to the C API, no C++ ABI, so let's say that Zig is more friendly towards in that perspective. But you have your Zig compilation unit, and now you can link everything together. And we do that, for example, also in the blog post. We take Redis and implement a new command in Zig that then we link into Redis. That's maybe not the correct way of adding commands to Redis, but when we wrote the blog post, the perspective was of us being the maintainer of a C project, where we don't start rewriting everything. We just add stuff as a separate compilation unit. And if you like Zig a lot, you can, if you want, start tackling your C project one compilation unit at a time, like you replace it with an equivalent Zig implementation, so you swap one piece at a time, and if you want, over time, you can rewrite it in Zig, if that's your goal. If that's not your goal, that's perfectly fine too, because the point is that since Zig can compile C code, and we have ABI compatibility, for example, there are projects out there that are just basically packaging a C project into a repo that has a build.zig file and maybe a Zig syntax sugar layer so that you can use the Zig file that gives you, nice Zig types instead of what the C API will return to you. But it's not even. But the second step is not even necessary. Even just having a build file would be amazing, and Zig would be able to use it.
Okay, sorry. Before we go any further, I should probably have prefixed this part of the episode, like the really technical deep down stuff. Before we lose the two members of the audience to listening, we should probably clarify a couple of things. LLVM, of course, is a compiler framework. Let's put it this way. That is available on GitHub and also has a fancy project website. You'll find the link in the show notes. Essentially, it's comparable to the GNU compiler suite in terms of it has a backend that is in charge of code generation for a couple of things, and then it has a programming language-specific front ends for the various programming languages. Rust is using LLVM. So if you invoke Rust-C, which is the Rust compiler, you essentially invoke the LLVM backend for code generation. Similar, the C-Lang or Clang that Laura's just mentioned would actually be the C front end and C++, and C-Lang++ would be the C++ front end for C and C++ programming languages feeding directly into LLVM. Now, Loris, the build system you mentioned, that sounds pretty much like something called Cargo for Rust. For those few people out there listening who do not know what Cargo is, essentially Cargo is the Rust equivalent, I'm simplifying things here, of the make or automake build system for Rust. Cargo can pull down dependencies, can compile dependencies and all the rest of it. So what make and automake and all the GNU toolchain equivalents took about, I'm tempted to say 10, 15, 20 years to really be user-friendly. In terms of simplifying things, it only took Cargo about, 5 to 10 years max. That's my personal opinion on the whole thing. But maybe, Loris, you have an opinion of yourself with regards to this build system that you just described in comparison, for example, to Cargo.
I think that's a fair comparison. To be a bit more precise, Cargo is also a package manager.
Correct, yes.
We don't have yet the package manager part, but we're going to start working on it in probably 3 months from now. So we want to also have that. It's just that we are slightly, it's a bit too early. But here's the deal. There's one thing that Cargo cannot do that Zig can do, which is compile C code. Cargo can fetch your C dependencies. So Rust projects can depend on C code, and they do that. But when Rust when Cargo sees that you have a C dependency, it uses the system's compiler, the C compiler that you have in your system.
Correct,
to compile
yes.
C. So in a sense, Cargo cannot fully work as a, if you will, build system and package manager for C projects. While Zig can compile and cross-compile C dependencies. So let me give you one example of how this is critical. And by the way, while this is, from this perspective, one thing that Cargo cannot do, it's not the end of the world though, because you can use Zig CC from Cargo. There are a couple blog posts out there. One I wrote myself called Zig Makes Go Cross-Compilation Just Work. And somebody else saw my blog post and did the same with Rust. And so there's another blog post titled Zig Makes Rust Cross-Compilation Just Work, where basically they had this Rust project that depended on a C library, and they configured Cargo to use ZigCC as the system's C compiler, and C++ also. And now they were able to cross-compile. So going back to the package manager / build system perspective, the aim for the Zig build system and package manager is to become a major C build system and package manager. If you want an example of this, I'm going to share a link with you all, both. There's a tweet by Mitchell Hashimoto from HashiCorp, which recently went public. So apparently Mitchell, I don't know, instead of enjoying the big money that comes from going public, I would assume, started packaging C libraries with Zig.
Shifting back from technical things a little bit. If I take a look at GitHub, the code base that is out there with regards to Golang and Rust is just overwhelming, especially the adoption of Rust in the last, I'm tempted to say 2 years, never mind the adoption of Golang. In the last 7 years has been amazing. Projects like Docker come to mind. And other more like system-oriented projects that require more like a low-level language like C or more. I'm almost tempted to say C++. Have adopted these two languages left, right, and center. Where do you see Zig in this context? And if I take a look at the code on GitHub, there are not that many projects out there that use Zig as their main implementation language. And by the way, of course, the language apparently is self-hosted, if I'm not completely mistaken.
Isn't that a factor of it being quite a young language as well, right?
Well, true, yes. And that's the reason why I'm asking about the roadmap here.
Yeah. So, maybe so first of all, let me acknowledge that, yes, you are right. There are not that many Zig packages out there yet. That is fair. It's also because, in part, there is no package manager. So you can imagine how surely it reflects the level of adoption, no doubt there. But also, you start having a proliferation of libraries and packages once you start having a package manager that allows you to easily leverage them. So we don't have that yet. So I think it's normal for these numbers to not be exploding yet. We'll see after we publish the package manager what happens. Now, okay, so this is libraries on GitHub. As for the language itself and being self-hosting, so the language at the moment is not self-hosted yet, sure, but we are about to. That's the current main piece of work that we are doing right now. Long story short, Zig is implemented in C++, but if we liked C++, we wouldn't be doing Zig. So we are trying to replace the current implementation in C++ with a self-hosted implementation. This self-hosted implementation, aside from being more to our taste, has a couple of interesting aspects to it. One is that it's going to be considerably faster than the current implementation. Zig is not that slow at compiling, but the new self-hosted implementation is really designed to be much faster. It implements many of the data-oriented tricks, in case people have heard this term. It's like just techniques to make your stuff go fast. And on top of that, we also want to implement incremental compilation with basically, let's say, a new way of doing incremental compilation that should be it should also allow us to basically do rebuilds of arbitrarily big projects in less than a millisecond. So the idea is you have a big project, you've compiled it once. Obviously, the bigger the project, the more it takes to compile it. There's no escape from that. But you have this giant project. Let's say it's, I don't know, Chrome or Zig Chrome, and you change one file, one definition somewhere. Recompiling the project after that one change should be basically instantaneous. That's what we're aiming for. And there are a lot of tricks that are necessary to get there. So this is the self-hosted work that we're doing right now. I'm personally working on implementing the doc system for the self-hosted compiler. That's what I'm working on right now. So the thing that basically generates documentation automatically for Zig projects. But it will take a while before all this stuff is complete. So as I was saying, I don't know, 3-4 months, something like this. After that, Zig will be self-hosted.
Interesting. So with regards to the overall ecosystem, you have a foundation in place, fair enough. So does Rust. So does, I'm almost tempted to say Golang, but we have this kind of tiny search engine behind Go, so that's probably an unfair comparison.
Are you sure that Go has a foundation?
No, that's what I'm saying, but it has a search engine backing it.
Yeah, I don't think it even does. I will say one thing, though. The Rust Foundation is very different from the Zig Software Foundation. Do you want me to go into the legalese?
By all means, just go ahead.
So Zig is a 503 non-profit foundation. 501c3, while Rust is a 501c6. So these letters, 501c3, 501c6, these are like, it's a pointer, if you will, into the specific paragraph and line inside some kind of American legal document that defines which... Yeah.
Exactly. Sorry, for the two people in the audience who are not American tax lawyers, lawyers is of course referring to the tax legislation in the US with regard to nonprofits.
Yeah.
Links made in the show notes.
Good luck finding them. I don't even know where to start. I guess you can Google the acronym. But the point is, 501c6, 501c3. Now, this is a tiny number that changes, but a 501c3, it's a non-profit foundation that can accept donations. a 501c6 cannot accept donations. So
Not even the ones under the table.
I mean, you mean lobbying?
I'm joking, Lawrence. I'm joking.
So they cannot accept donations, and so the Rust Software Foundation is not allowed to accept donations. The only thing that they can do, well, I guess they can do work, just like the Zig Software Foundation can do work and being paid for work. But what the Rust Foundation basically, the way they get money is by having member companies pay a fee. So in some ways, they are more like a consortium. I think that here in Europe we would think of that type of organization as a consortium. So they are a group of companies with a shared interest. Companies pay a fee to get into the foundation, and that's it. One interesting side effect of this is that the Zig Software Foundation is paying its developers. I am being paid by the Zig Software Foundation to work full-time on Zig, and so are a couple more people. At the Rust Foundation, nobody is paid to work on Rust, except maybe a couple of people who have administrative tasks. So the developers are not paid to work on Rust.
I think the fundamental difference is similar to Linux. The people on the foundation are employed by different companies who are just chipping in with regards to making the project work, whereas Zig seem to be different, apparently, in that case.
Yeah.
Okay.
Yes. Also because there are sometimes, I think, some interesting conflicts of interest, I think, when you have the second approach, the one where you have companies, or the first approach, as you say, the one where you have companies basically hire your code contributors. Because on one hand, you have this, if you will, natural misalignment of incentives where a company is paying these people to work on their stuff, and secondly, to work on Rust or the other open source project, whatever that is. But it's not just that. Like, one thing that happened recently with the Rust Foundation, which I found not very nice, was that Rust had an executive director. There was somebody from the Rust project itself that had been there for a long time, and basically this person was the executive director at interim, so only temporarily while they were searching for somebody to take the position full time. But he basically never renewed her contract after it expired the first time, and the foundation remained without an executive director for something like 6 months or something like that. And in the meantime, when you don't have an executive director, the highest authority is the president of the board of directors, who was the person in charge of the Rust team at AWS. So AWS, basically, it's one of the biggest member companies. They have a bunch of board seats. They have the president, the chairwoman of the board of directors at the Rust Foundation, and they also employ a good chunk of the key developers of the Rust project. And I don't know. I think that when you have an external organization, whoever that is, for me, it's very easy to hate on AWS. But whatever the company is, even if it's not a company, where they ask employees to pee in bottles, even if it's a much nicer company, it's still a problem, in my opinion. So one thing that we do in the Zig Software Foundation is that we know up front that we are never going to give board seats to any big tech company, period.
Okay, interesting. Okay.
Although now you might say, well, okay, then how do you guys ever expect to become big? And that's an interesting...
Well, what is the objective? But first of all, you mentioned the donations. So these are sort of no strings attached donations to the project. Is that right?
Yeah, correct.
And then the second question that follows on from that is obviously the people like yourself and people developing the language. How do they earn their bread on the table. Let's put it that way, right? This is where organizations that sponsor Rust programmers, that helps or any open source project helps the project move along, right? So that's if in your case it's mainly done on a voluntary basis or as a sideline, then you can perhaps imagine it will take longer to take off. Is that fair to say? Or how do you see that?
Yeah, so I think that from a development velocity perspective, I don't think that not having a big company sponsor us makes much of a difference. I think it does make a gigantic difference more from a marketing perspective, because even though, for example, Rust deserves, I think, to be regarded as a very interesting new language and absolutely innovative when it comes to the borrow checker, etc. Well, I mean, you can also see that, especially now that AWS is in charge, there's a lot of marketing money being spent into Rust stuff. Like the hype level is pretty high, and marketing money is being invested into, keeping the temperature high. In some ways, you could argue the same about Go. I don't know precisely how much marketing investment there has been in Go, but the fact that Google uses it, and then once it starts being used for one big project, then by the fact that it's baked by Google, then that's all stuff that helps for sure. For Zig, when it comes to paying core contributors, it works this way. We have 3 contributors that work full-time and are paid to work full-time. I'm one. Another one is Jacob Konka, who left Microsoft to basically work on a in-house linker that we are using in Zig. I won't get too much into detail, but the idea of cross-compiling, like making a program, compiling a program on Windows for macOS, it's not trivial, and especially with the new macOSs that came out, there was no linker able to do that, and so Jacob started working on this stuff. But aside from these technicalities, and the third person, of course, is Andrew. Us 3 are the full-time contributors right now. Then there is a group of about, let's say, 10 people who are not working full-time, but who have contracts where they are allowed to bill hours to the Software Foundation. So they do some work, and they are allowed to bill a few hours every week. I don't know I don't remember the precise details, but you can think of it as like a and lower than part-time, something like this. These are current state. Obviously, the more donations we get, the more people we would like to bring on board to work full-time. But the general idea is that we want to always stay small, like a tiny organization, no overhead as much as we can, so that we can stay tiny, and more importantly, that we don't end up like depending too much on one donor, on one big company, something like this. We don't want to end up like Mozilla, who at one point had to fire a bunch of very good people just because they ended up, just because then one deal that they had with Google ended up not being renewed, and that was a disaster. From a marketing perspective, obviously, not having a big company in your board of directors, it's tough. They have money, and money is easily translatable into marketing muscle. I don't know, you can have a Zig conference organized and entirely paid by this giant company, and that surely helps. We're not going to have that, but at the same time, I think that we are solving problems that are interesting enough that people have started to notice. I showed you earlier a tweet from Michel Hashimoto, but we started, for example, recently being paid to offer a support contract to Uber, where they started basically to use ZigCC to cross-compile some stuff on their end. And they wanted us to fix some corner cases with like old Linux glibc versions and stuff like this. And I think that if we play our cards right, for example, I'm not really being paid to work on Zig, the compiler. I do that as well, but my job is more marketing focused. So if you look for Zig on Hacker News, you will find a good number of things that I've written in the past that has reached the front page. I'm not the only one, but this is part of our strategy. So we are more, I don't know, guerrilla style marketing, if you will.
Which is an interesting question, and of course the links will be in the show notes with regards to the stuff that Loris just mentioned. Loris, if I take a look at the spreadsheet, I see quite a few companies outside the realm of the usual suspects that have picked up on Zig. But of course that pales with regards to the Googles of the world and the Mozillas of the world and the Microsoft of the world. I mean, there was a statement last year, or was it before? I can't remember, where somebody officially from Microsoft said that, in a nutshell, I'm simplifying things, of course, that Rust basically will be the next C++ at Microsoft in terms of it's that technology stack that will be replacing the workhorse that has served Microsoft for at least 10 to 15 years as the main implementation language for Office software, for some other quite interesting stuff over the years. Where do you see this in terms of the overall industry adoption going for Zig?
That's a good question. I don't have so I didn't know about this Microsoft stuff. It doesn't surprise me. It kind of makes sense. I can tell you that my knee-jerk reaction is I don't honestly care which language they use to implement ads in my start menu. So I'm kind of jaded when it comes to Microsoft specifically. But this is not about Rust. This is about Microsoft specifically. But if you want another example, another recent example, where Rust started being adopted by an important project, and actually in this one, Zig apparently was in the race too, but we lost to Rust in a sense, if you will, is Ruby. There was a discussion in the Ruby forum discussions with the creator, Mats, where they were discussing re-implementing a component of the compiler, the JIT part of the compiler, from C to either Rust or Zig. And then the contributors were asking the Mats, the owner of the project, if it was fine to use Rust or Zig, and then they ended up choosing Rust. So that's fine too. Honestly, from that perspective, I think that Rust and Zig are different enough that people that would want to choose Rust should choose, and they really like Rust, they are not going to be happier by choosing Zig. I do think that there are a lot of people, though, out there who would not be super happy to use Rust, and they would be happier to use Zig. And yeah.
In interesting perspective, taking a step back now, if I take a look at the ecosystem, starting, for example, with Python has been around for the last 30 years. Golang has been around for 15, 17 years, something like that. Rust has been around for 10 years plus, give or take. When I take a look at the crates.io ecosystem, it reminds me of PyPy, as in the Python package index, that took, in terms of functionality and packages overall available for any purpose, parsing websites, anything basically. If I take a look at Rust, I'm tempted to say that it took the Rust community about 10 to 11 years to get to the point that the Python community took over 25 years to get there. If I take a look at the Zig ecosystem, I don't think it's quite there yet. Okay, fair enough. You have been around for 7 years, so it takes a while to build an ecosystem. But if, as far as I'm concerned, actually a language and the adoption of a language or tech stack in general lives by the ecosystem as such. Where do you see Zig going in terms of overall community adoption, especially when it comes down to the module ecosystem?
Oh, I can tell you very easily how we're going to do much better than Rust. So
I'm all ears.
So here's the idea. Rust is a fuzzy language in a sense. So fuzzy as in picky, because when you're using Rust, if you want to make good use of all the things that Rust gives you, you don't really want to jump into C code, do you? Because C is unsafe, right? And you have to
Correct, yes.
close everything in unsafe brackets, and it makes interoperation hard. In Zig, we're not that fuzzy. In Zig, we don't mind bit fiddling. We don't like undefined behavior, so some C stuff maybe won't compile correctly. Zig, by the way, compiles everything with undefined behavior sanitization, so not every C library can be used right away, but the ones that don't have undefined behavior in them can be used, and we are not as picky as Rust. Surely we would prefer a Zig implementation over a C implementation of something, but there is less of an impedance mismatch between Zig and C than it is between Rust and C. So, long story short, from Zig you can make use much more easily of 40 years of C libraries, and this is how it's going to start. The start is not going to be, let's say, re-implement everything in Zig. The start is going to be, let's package already good C libraries that have been out there since forever, that are basically currently being used everywhere, that are like critical infrastructure of modern technology. Let's repackage that from Zig so that we can use it more easily, and boom, now you have everything. It won't necessarily work in every single case, but the point is, we are not rejecting existing C libraries. We are embracing them, and it's much more easy to just fix the build script so that it uses build.zig of an existing C libraries than it is to re-implement it from scratch.
Interesting perspective, especially from full disclosure, I'm a little bit of a Rust fan, but fair enough. Apparently, we both share that passion to some extent, Loris, but let me take a look at it from a Rust perspective. Rust gives you, I'm tempted to say, a very low technical depth in terms of if you can convince the Rust compiler to generate code, the QA phase in terms of fixing bugs and especially when it comes down to memory stuff is pretty short. C, on the other hand, you just go ahead. If you want to shoot yourself in the foot, that's fine. Now, I see Zig, if I understand the language correctly, somewhere in the middle. You can do a lot of things that you can do in C, and what you just said confirms this to a certain extent if you want to reuse C libraries. But Rust is explicitly, on the other hand, basically tells you, sorry, you have to know what you're doing in terms of if you're using an unsafe crate, you better know what the implications are. Because normally, and that especially goes for the ecosystem that is out there for us, you are bound to save code. And so combining the crates, and this is very similar to Python these days. When I program Rust, first of all, I'm going to take a look at crates.io to see what's out there. Similar, if I want to do a code base in Python, I normally check out the Python package index, because most of the time, and that goes for Rust and Python, I simply end up writing glue code. But if I check out Rust, in terms of if I stick to Rust, once I basically have my cargo definition file as in cargo.toml done, which is I'm simplifying things, in the equivalent of a make file for C, the Rust compiler basically, because we're mostly talking about safe code, guarantees me assured turnaround times in terms of debugging, especially when it comes down to memory issues. Now, where do you see this total cost of ownership, especially with regards to technical depth going in terms of Zig adoption?
Yeah.
If that makes any sense.
It does. That's definitely an open question. And obviously Rust is a very good makes a very good proposition when it comes to safety. And ultimately, I agree with you. The ultimate point is, what is the total cost of ownership? Well, let me ask you a counter question. But I would like to reiterate, I do believe that Rust is making a good offer. So I don't want to dismiss that. That said, which one would you prefer? Also, from a perspective maybe of ease of use, being able to just import a Rust crate into your Rust project is obviously super easy. But from a perspective of total cost of ownership, or like the risk of bugs, right? You mentioned risk of issues with memory management, but memory management is one source of bugs, right? There are also many other ones. So,
of course, yes.
Would you trust more using a newly minted Rust crate that basically is a re-implementation of curl? That's what I wanted. Okay, so
curl. Okay, yes.
So from the perspective of total cost of ownership and bugs, yes, Rust covers memory bugs or memory usage bugs beautifully, but those are just one source of bugs. So which one would you prefer? A newly minted crate that is a reimplementation of curl, or curl itself? Because curl itself is surely it's a C project with all the danger that comes with that, but at the same time, it's very, very battle tested. So which one would you prefer?
Interesting question there.
I'll go for the original curl. Yeah.
I would take a look at the GitHub issues page. Yes. No, joke aside, Loris, you're absolutely spot on. That's a tough one.
That's a tough one. Yeah. So my whole point.
I would probably take a look at the adoption figures of Crate.io to see who's using this newly minted curl implementation. To see what's happening. I don't know. Give it a half a year, but for the meantime, I probably would be. I'm reluctant to say this. But I would concur with Martin. Yes.
So
although it's unsafe code.
It is unsafe code. Yes, but at the end of the day, my point is that there's a lot of good that comes from Rust, but it's unclear to me that is the ultimate silver bullet when it comes to total ownership cost of something. And I don't believe that throwing immediately in the trash 40 years of C code is the right choice. I'm being a bit too extreme here, maybe because
I'm with you. No worries.
Yeah. Rust can interoperate with C, but I think that more in general, especially for domains where memory management is not that complicated, while other sources of bugs are really more the problem, like, I don't know, distributed systems, memory management most of the time is not complicated. Like, you have a request and memory has to live for as long as the request survives, and you can do that with an arena locator. It's super easy. The problem, though, is that in distributed systems, you have a bunch of problems that come from the nature of distributed systems, and those are bugs where Rust can help you to some degree, but not 100%. And again, not to dismiss Rust. Rust is amazing. This is all good. The point is, it's not the ultimate good that nobody ever will able to.
Agreed. Yes, absolutely. Because that hasn't been invented yet. Exactly. No, I mean, jokes aside, Loris, I mean, these three languages, and Golang goes along the same lines to some extent, are targeting one specific area, namely system languages for system-oriented programming. Zig is in that area. C, this is where C comes from. Unix was implemented in C, and that's exactly what Mozilla had in mind when they, more than 10 years ago, took a very serious look at something called Rust. A system language designed for system-specific things. And if you take a look at the crates that are out there, much of the stuff is actually targeted at system programming. Goes without saying, like the one you just mentioned, like curl.
Yeah. So I think that the idea of packaging curl as a starting point, and then maybe slowly over time, after you have come to an understanding of how you think it can be improved, because I think that rewriting without improving the interface, maybe it's not the best use of time. Let's just let me just put it that way. So the plan is to have people just reuse what's already out there. That's already pretty good. And then only rewrite once you know how to improve on the original interface, on the original APIs and stuff.
Okay. Yes. You're listening now to the edited version of this episode. The original version went about for 4 hours. We went into the low-level compiler details, but this, of course, has been edited out. You may find the original version on something called Inlaws.eu. But jokes aside, no, Loris, let's wrap this up. It has been more than interesting to hear your perspective on things, especially where you see this going. There is, if you've listened to a couple of episodes, there's something called the Poxes of the Week, where we simply discuss things outside the topic of the current episode, as in anything goes. The Poxes basically are about things that you think worth mentioning, like books. Martin normally refers to movies, especially his drug habits and some other stuff. Mm-hmm. Like designer drugs and so forth, but really anything goes. So, Loris, what is your pick of the week, also known as a POX?
Let me think. Oh man, I don't know. I can only think about what I'm doing for.
You're put you on the spot. Okay.
Why don't you go first, Chris?
You see, I'm almost tempted to say Miami Vice, as in the TV series from the 18s. I've just discovered. Yeah, indeed, yes. But then I'm old, so that's okay. No, I jokes aside. I've just discovered this recently, and I used to watch this left, right, and center in the 80s, and it brings back fond memories. But without into the finer details, Martin, what's your box?
That's a good question. I'll have to have a think as well. I don't think anything specific.
You have about 10 seconds. You could mention your wife.
I can go in the meantime.
So, go ahead.
Yeah. So if we talk about movies, I rewatched this weekend the original Lord of the Rings trilogy, and
yes,
it was nice. I don't understand though why certain phrases became memes. Like they are taking the hobbits to Isengard. Why? Why that phrase became so much of a meme that they made songs with it?
Did it? Okay.
Yeah, there were like YouTube videos with basically this sentence repeated as part of a song, but there was only one, right? Also, the other one, you don't simply walk into Mordor, something like this.
Which goes to show, Loris, that you're about 30 years younger than Martin and myself are.
Oh,
I don't even know what Mary Vice is.
Give or take a few anyway.
Like, one does not simply walk into Mordor. I think that has been memed so many times. I can't even count how many I've seen of those.
Okay.
But yeah, anyway, it shows that, I guess, internet culture has changed from that time to today, because nowadays, I don't know, in some ways the memes seem weirder, the movies worse, but the memes are at least more relatable, I think, than in the past. I never understood them, the past ones.
Okay. Martin.
Okay, since we're sticking with movies, I'll go with a movie called Land of the Blind, which is I watched at the weekend. It's from 2007, but it's quite.
It's a BBC production.
I don't think so, actually. But it was quite amusing.
In the show notes.
In that. It's basically about someone overthrowing a dictator with a revolution, and then the revolution becomes the new dictator. So it's kind of, which is even worse than the original dictator. So it's kind of, know your enemy, really, is the moral.
Parallel to the modern world, like bug number 1 for a certain Mark Shuttleworth are purely, what's the word I'm looking for, incidental. Coincidental? Inspirational, whatever. Jokes aside, no, links maybe in the show notes. Loris, that has been more than inspiring. Thank you for thank you for taking the time.
Actually, what we missed is if people want to become involved in Zig.
Yes.
How would
the
they?
plug, Loris?
Yeah.
Go ahead.
Yes.
How can people help?
How can people help? People can help, I think, in 3 ways. One, by contributing code, if that's what they like to do, because it's an open source project. You can go to github.com/ziglang and you will find our organization with repositories, and we have weekly meetings on to help people contribute to the language. Number 2 is, of course, donating money. We have a GitHub sponsors page still on GitHub. Also on the website, there's a big link at the top. So if you go to ziglang.org, at the top there's a big link that tells you how to sponsor the Zig Software Foundation. And I think it's also an interesting place. It's an interesting page to read because it explains how the organization works, even if you don't plan to donate. And number 3, and this is actually my favorite, you can contribute just by paying attention. Because all these things that happen in open source and how open source organizations interact with one another, having people see what's happening really can make a difference. When nobody's watching, organizations, open source organizations can behave in ways that you wouldn't expect from an open source organization. Recent events in the .NET Foundation, for example, are relevant to this point. And and more in general, knowing what we are doing helps us also protect ourselves from people misinterpreting, deliberately or not, our intentions and actions. So that's my favorite way of contributing.
Yeah, great. Last question from my side, Loris. What is the license for Zig? What liberal one, like Apache or MIT or something?
Good question. Yes, it's MIT.
MIT. You heard it here first, people. It's a very liberal license, so
Yes.
you can take the source code and do pretty much whatever you want with it.
Yeah, and it's deliberately non-GPL. Like it's deliberately non-complicated for companies. Let's just say.
Yes. People, this is a non-communist license, of course, because it's not GPL, as it's not part of the GPL license family, but that's okay. We do make exceptions on this podcast. Jokes aside,
That's another complicated story, maybe for another episode.
People, Linux Inlaws .eu is the go-to source for the episode list. Pick and choose your episodes with regards to communism. We do have a 5-year plan. There are regular cadence updates on the podcast, how we're doing with regards to the 5-year plan. Yes, exactly. And don't forget to check out the dark side, just in case. But enough plugs. Loris, thanks again for being here. Hope to have you back soon for an update on Zig, and all the best with the project.
Thank you. It's been a pleasure.
This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
in the Zig community, we start calling this stuff like that's a Linux moment. When you're using Linux and like your mic doesn't work or your screen share doesn't work,
Yes,
and it's
indeed.
it's a Linux moment.
That's a Linux moment. Have you copyrighted this term? Because it'll be in an hour. No, I'm joking.
You've been listening to Hacker Public Radio at hackerpublicradio.org. Today's show was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hosting for HPR is kindly provided by anhonesthost.com, the Internet Archive, and rsync.net. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.